After this, we also need to find what is C2. One thing we can assume that when charge is 0, our current is also equal to 0. What is current? Current is function of Q, which is given by dq by dt. So this is our Q, then our I will be dq by dt. So we take the derivative of this term with respect to t. So derivative of sine t will be n cos of nt minus e upon 2ln our constant, and here we have t into cos nt, that is derivative of u into v. So derivative of u into v is nothing but derivative of u, so derivative of 1 cos nt will remain as it is, plus derivative of cos nt is nothing but minus n sin nt, and t will remain as it is. So this is our current. When charge is 0, current is also 0, and when current is 0, time is also 0. So when charge is 0, the current flowing will also be 0, and since charge is 0 at t equal to 0, so time is also 0. So we put time is equal to 0, so this term will become 0 and this term will also become 0. So when we put time equal to 0, this term will become 0 and we get 0 equal to n into C2. Cos nt is 1 because cos 0 is 1 and this is also 1. So n C2 minus e upon 2ln. When we take this part here, we get n C2 equal to e upon 2ln. I can take this n in the denominator, then we can get C2 as e upon 2ln square. So this is our C2. Now we substitute this C2 in this equation, we get Q equal to C2. We have calculated C2 as e upon 2ln square. Then we have sine of nt, so sine of nt minus this term which is et upon 2ln cos nt. So et upon 2ln cos of nt. We know that in the given equation we are given n square equal to 1 upon LC. So we can substitute n square equal to 1 upon LC. So we get e upon 2l. Instead of n square we can write 1 upon LC into sine nt. Here also if I multiply and divide by n, we get n upon n square. So et, and why we are doing this, because if you see here we have 1n. So that's why we are multiplying and dividing into cos nt upon 2l, and instead of n square we can write 1 upon LC. So now we can cancel this L and we can take this C in the numerator. Similarly here, so we get EC upon 2 into sine nt minus EC upon 2 into nt cos of nt. So if you observe what we need to find Q equal to EC by 2 sine nt minus nt cos nt. So here also if you see this equation is very similar, we just have to take EC upon 2 common, then we get sine of nt minus nt cos of nt. So this is our final solution, and this is how we solve the problem on application of differential equation. More such problems we will see in our next video, so stay tuned for our future lectures.